Hello, Mr. DRAM. I'm Wyatt Kirkpatrick, and today I will be walking you through the 2012 AB Calculus AB Free Response. Section 2, Question 1. We are given a table of values for the temperature in a tub of water and the corresponding times of minutes. We are told it is a twice differentiable function, so we can take the second derivative and all of that nice stuff. Yeah. So for the first part, part A, it is asking us to estimate W prime of 12. So we are given conveniently two times that when averaged will give us 12, 15 and 9. And so W prime of the degrees will just be the rate at which the temperature within the water is changing. And so to calculate that, we will take the 15 value, or the temperature at T of 15, subtract it from the temperature at T of 9, and then divide it by 6 because 15 minus 9 is 6. So 67.9 minus 61.8, 6.1 divided by 6. So at time of 12 minutes, the temperature in the temperature within the tub is increasing at a rate of 1.0166 degrees Fahrenheit per minute. So now for part 2. Use the data in the table to evaluate the integral of 20 to 0 W prime of t. Interpret the meaning of this in the context of the problem. So integral of a derivative cancels it out, and so it just ends up being final minus initial, or the total change. So the final value for t on this table is 71, and we would subtract that from the initial 0. So 71 minus 55 will yield 16. So in the context of the problem, this means that from the interval of 0 to 20 minutes, the temperature in the tub increases by 16 degrees Fahrenheit. For part C of the problem, we are told that the average temperature in the water is given by 1 over 20, integral of 20 to 0, Wt dt. Use a left-Riemann sub to approximate this value. Is it an overestimate or underestimate? Explain. Left Riemann subs is going to be our total change in time, and then we pick the left value for the corresponding y-axis. So in this case, we would pick left values for our Fahrenheit. So for our first Riemann sum, excuse me. So we would do, for our first part, we would do 4 times 55 plus 9 minus 4 is 5. 5 times 15 minus 9 is 6, so excuse me. So, and then 20 minus 15 is 5, and then left value times 67.9. And so then this is way too high, so we have to remember to divide by 20 here. So this is our left Riemann sum approximation for the average temperature in the water, 60.79. And so this is going to be an underestimate because we always use the smaller values. Now, the way that you actually want to phrase that is because the my apologies. Because the integral of Wt is increasing and you are using the left Riemann sub, you are always using the smaller values. So a good way to visualize this is if you have a roughly linear graph, you take 2 points and you use left Riemann sum, You're not counting this area, but you're counting this area only, so it's going to be an underestimate. Sorry, I'm still a little bit sick. Now, for part D, for time of 20 to time of 25 minutes, the function w that models the water temperature has the first derivative given by w prime of t is equal to 4/10 root of t cosine 0.0t 6t. Based on the model, what is the temperature of the water at t equals 25? So note this function only applies for 20 to 25, and this is prime, so this is the rate at which it is increasing. So we cannot just plug in 25 as a value of t and then use that as our answer. So that being said, what we will want to do is we will want to take the t value at 20, 71, and we will want to add that to the integral of 25 to 20 of this. Because the integral of a prime, or the integral of a derivative, is simply total change, which is sort of what we did in part B. Now, I don't really have a way to show this, but I plugged it into my graphing calculator and got that the integral of w prime from 25 to 20 was 2.043, and so we would add that to 71 because that's only the change in temperature from 25 minutes to 20. So we would want to add 71, which was the temperature at 20. So that means, based on this model, the temperature of the water at 25 minutes is 73.043 degrees Fahrenheit. And that should be all you need to receive full credit on the calculation. That should be that is all you need to receive full credit for the 2012 Calculus AB Free Response Question 1. Thank you for watching, Mr. DRAM. I apologize for my coughing.